Everybody. Through this lecture, we will uncover the key principles related to the baked column, analyze practical challenges, and discuss solutions used in real industrial environment. My aim is to deliver the subject in a clear, structured, and engaged way so that every idea become easy to understand and ready to apply. When we talk about the backed column versus the tray column here, the backed tower is known as continuous differential contact equipment. No specific stage found. Okay, so here you will see the backing in the tower. Okay, here is a distributor for this is the device for the feed inlet, liquid distributor, and this is the bed. The contact between the liquid and the vapor, the liquid is liquid direction from top to down, okay, and the vapor from down to top. Here is the contacting media, here is the surface, and I need to increase as much as possible the surface area, so I put even stacked backing, organized or random backing. In this shape you can see easily the random backing. Okay, so we give the definition for the backed tower as continuous differential contact equipment. Continuous because there is no hold time at the tray. When you work with the tray, there is a hold time above the tray and the contacting between vapor and the liquid. Here, continuous differential contact equipment, no specific stages. Okay, it is different from the stage-wise absorption column or distillation column, different design approach. I want roughly to describe this statement. There is a deep knowledge about this statement, but roughly, what is meaning by different mass design? When you design the tray tower, you calculate the theoretical number of the tray, okay? But when you design the backed column, you transfer the number of the theoretical trays into diameter and height by some numerical equations. Okay, so you transfer 10, for example, number of trays into height and diameter. Okay, then you select the type or suitable type of the backing you will install inside the column. Okay, this is the idea generally. Okay, here in this tower, you can see easily there is a backing side above and a trade side down. Okay, for sure we can find the mix both of them in the same in the same tower. Some cases will prefer trade tower. Another cases will prefer bagged tower. Which one of them will support choosing the packing, and we will know in detail which cases support selecting the trade tower. Backing are generally more expensive than plates. Okay, the difference in the column height is not usually significant if the flow rate are such that efficient are near the maximum. As a rule of thumb, the blades are always used in column of larger diameter. What we mean by this statement? For the narrow diameter, for the small diameter, remember all time selecting the backing column, because when you make your design and you find the diameter is so small, it is not recommended to install trays. How you will install trays? And we mentioned before that there is a manway related to each tray, and there is the weir and the liquid down cover. How you will install all this equipment if you are working with small diameter? For the small diameter, it's recommended to go to the bagged tower. This is the meaning of the statement. If tower that have more than 20 or 30 stage, recommended to go to the tray tower, because you cannot transfer this huge number of trays into the baking. Okay, as we mentioned in the calculation, the number of the tray will be switched to diameter and height. Okay, there is some conditions favoring baking a column. Some condition will support choosing bagged tower. Bagged tower. Step by step, small diameter. As we mentioned before, small diameter recommend baking because it's hard to install the trays. Less than 0.6 meter. More choices in material of construction for baking, especially in the corrosive material. If you are work with a corrosive material, this recommended to choose baking because it's easy to change baking. Otherwise, it's expensive to change all the plates or the trays through the tower. Lower pressure drop. And for this reason, especially in the vacuum tower, we select directly bagged column. Okay, less liquid entrainment and low liquid hold up, especially suitable for thermal sensitive material. Okay, because the trays give you residence time to hold up the liquid, but the backing no. So if it is less liquid entrainment and low liquid hold up, you have to choose bagged tower. Foaming liquid can be handled more easily through this type of tower. There is some conditions favoring blade column. Now you will choose, it's favored to choose the trade tower. Variable liquid and vapor load, more controlling through the trays, okay? Low liquid rate, because as we see in the bubble cap, low liquid rate, it will not weep. Why? Because we have good control by the bubble cap. So if you are working with low liquid rate, recommended to choose trade tower. Large number of stages and the diameter, choose trade tower. High liquid residence time is required. If the residence time required is high, you have to choose a trade tower. Dirty service, because dirty service in the backing, you will lose all the backing. Here you can shut down and easy to clean. The presence of thermal or mechanical stress due to large temperature change with might lead to cracking or something like that. Here there is more control related to the temperature using side stream, side reflux, and something like that. Okay, exotherm requiring a cooling coil inside the column, for sure recommend the trade tower. Okay, so now we make a little comparison between when to choose backing, when to choose trade tower. Okay, backing requirement. This is a chemically inert, the fluid reaction corrosive resistance. You have, when you choose the backing, to know that when you choose the backing, you should remark and consider the backing material should be inert, not to react chemically with the vapor or the liquid. Okay, and also the mechanical strength. Mechanical strength will prolong the time of using this backing, and also the wide volume, because this is your tool to make liquid vapor contact, and you want to maximize this contacting and maximize this surface area by this vial. Also the surface area provide a good contact between the liquid and the gas. Okay, the cost, you can choose backing with higher cost and low cost, depend on the corrosivity of for the liquid and the vapor, and the reactivity of the liquid and the vapor with your choice, if it is from plastic, from metal, from ceramics, or something like that. Okay, fluid resistance, the backing material should not trap suspended solid present in the liquid. And bigger backing material generally give low fouling resistance. Here, as you see, this Russian ring, which compose the backing, common material metal. Metal here backing are usually preferred because of their superior strength and good wettability. Okay, plastic, inexpensive. If your budget, your capital cost is low, you can go with plastic choice. Okay, poor wetting, particularly at low liquid rate. Maybe ceramic. Ceramic useful for resisting corrosive at elevated temperature. Good wettability but inferior strength than metal backing. So there is a choices, and you have to decide it. What is the type of the liquid? What is the type of the vapor? And after that, you have to choose the type of the backing material. Here we will see the type of main type of the backing, which is stacked backing or organized or random backing. Random backing, there is a many component to compose the random backing. Okay, as we see in the graph here, it's clear the bell type, interlocks type. Okay, this is another shape for the backing, because there is many types of designing the backing, and all of them directed in one way to increase the surface area and to contacting time between the liquid and the vapor. Why? Because we said it is a continuous contacting machine. This is baking. Okay, there is no hold time like the tray. Okay, this is our target or aim from this different shape and type for the backing. This is the shape of the random backing. Here, as we see, this is random backing, okay? And there is two ways to install inside the tower. Here we have the stacked backing. This is stacked backing when low pressure drop and very high flow rate. Stacked or oriented backing are used. Favor decrease in pressure, decrease path length of flow. This is the stacked organized backing. The structured backing here, there is a types for the structured backing. This structured backing usually offer less pressure drop and high efficiency and high capacity. So we recommend a little bit if you are working, if you are targeting the higher capacity, the higher efficiency, the pressure drop, okay, effectively contacting time, you need to work with structured backing. This is more recommended, okay. But if you need or target mixing or good mixing to make turbulence flow or something like that to ensure the good mixing, you can go with the random backing. Here, I want to clear to you, there is two types to install the backing inside the tower. There is a dry process and wet process. This wet process working in as the following. You bring the tower and fill the tower with clean condensate. Then you empty the bags of the rushing ring, for example, inside this clean condensate with the elevation and the head. When you fill the tower with this rushing ring, you start to withdraw the clean condensate. Then you will get your rushing ring stacked layer after layer inside the tower. This named by wet installation process. And there is a dry process like soak loading. Soak loading is easy like the catalyst to install the rushing ring inside the tower. Each process recommended in some cases, like the dry here shoot and soak, this is for the dry. Rope and the bucket, this is for the dry. Dry backing, avoid high hydrostatic liquid head, prevent the introduction of water, not recommended to use water or clean condensate. Quicker, okay, less expensive, and minimum rust of metal backing. So not but if you are working with the wet process, it's not recommended with the plastic type. Why? Because the plastic will float on the water and the distribution will not be in a good shape or good manner related to the installation process. Okay, so because the plastic float inside this clean condensate or water. Here the shape of structured backing, and we have to consider that enhance the surface area, elevate the efficiency, minimal pressure drop, and the consistent liquid distribution. Example, mill back and the flexi back and the gym back. This is the structured backing. Okay, you have to know when to choose the structured backing. Here the random backing key characteristics is the turbulence and the mixing between liquid and the vapor, versatile for many choices. Okay, mechanical stability and the cost effectiveness, because this cost effectiveness very important and considered during the design case, and capital cost and the budget specifying. There is examples for the random backing like rushing ring and the bell ring and interlocks saddle. This is type of the random backing. Here the structured backing versus the random backing arrangement. Here you can remark that the components are placed in a specific repeating pattern, providing a high and predictable surface area for vapor liquid contact. This is important related to the structured backing. Also the pressure drop, which is very important here. You have to know that engineered to maintain a relatively low pressure drop across the column. Here typically results in a higher pressure drop. Why? Because it's random. It's easy to understand something like that. So the pressure drop better related to the stacked or organized backing. Structured backing versatility suited for application where high efficiency is crucial, cost often more expensive. But the random backing here versatile and adaptable to various applications, many applications in the chemical processing, okay, and generally more cost effective than in comparison to structured backing. Structured backing mechanical stability offer a good mechanical stability due to the organized and supported structure. Here, the random backing generally mechanically stable and irregular shape provide resistance to damage because it is not organized. The mass transfer, you have to consider promote efficient mass transfer between vapor and the liquid phase, but in the random backing induce turbulence facility, vapor liquid contact and the mass transfer. So if you want to make a good mixing, if you want to make turbulence flow, you have to choose the random backing. Okay, structured backing here examples is clear like mill back like this or flexi back like this. Random backing as we mentioned before, rushing ring, interlocks and bell ring and something like that. Okay, so finally I want to appreciate your good listening for this lecture. It's very important to make comparison between the trade tower and the bagged tower to know the differences, when to choose bagged tower, when to choose trade tower. Finally, I want to thank you and as we used, appreciate it. Thank you.